Hey students, this is lesson 832. We're going to look at some quadratic equations and their graphs and see if we can't figure out what making a little change to the equation will do to the graph. I'm going to skip right to this group 1 here, and what we're going to do is we're going to use our calculator to graph these equations, and then we're going to look at how they're changed and see if we can't make some predictions according to what we see on our graphs. So I'm going to pause here and just get the graphing calculator set up. Alright, so here I have the three equations in group 1, and now we're going to set up our window so that it looks like the graph that you have in your packet. And you'll notice that the smallest value on the x-axis is -3, so we're going to make our window go from -3, and then the greatest value is 3. The scale is 1, and the y minimum looks like it's -2. And the y max looks like it's 12. And then y scale is 1. So I'm going to graph these, and there's what it looks like. And you should, what we're going to do now is describe how they're different. And one thing you should notice is pretty much the curve of all of them is the same. The y-intercepts, which happens to be the same as the vertex in this case, are all different. And we're going to try and describe some of those differences here. So first thing I want to do is sketch my graph. And you can do it fairly accurately because you know what y equals x squared looks like. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So we can get that pretty accurate. And then we know it's symmetrical. Then from there, if you just look closely at those graphs on the calculator, you'll notice that it looks like this is just up 1 and this is up 3 from the original graph. So if you want, you can just sketch in and just make sure that the y-intercept goes through the right place there. So there's our three graphs, and then we need to label those. This first one is y equals x squared. This one here is y equals x squared plus 1. And this one here is y equals x squared plus 3. And now in part B, we're gonna say what similarities have and what differences they have. One thing you probably notice is they're all curved about the same. So they all have the same curve. They all open up. In other words, they have a minimum. They all have the same line of symmetry. And the line of symmetry is x equals 0. And some of the differences is pretty much the only difference is that the y-intercepts are different, or the vertex is in different places, however you want to say that. So those are all the things that they have the same and different. And then for part C, we're going to just try and think of one other equation that would be in the same group. And I think something like x squared plus 5, and you really could add anything to that and it would be in the same group. All right, I'm going to skip down now and do group 3. We'll do group 2 in class. So group 3, you'll notice right away that none of them have anything added onto them. So what you should be thinking is that the y-intercept of all of those is 0. The thing that's different is the coefficient of the squared term is all different in those. So let's set up our calculator to graph those. So I got those equations in. We have to change our graph a little so it looks like the one in your packet. It looks like the only thing that's really changed is the y max is now 18. And other than that, it's pretty much the same. So I'm going to graph these three now. And one thing you should notice right away is that they all have the same y-intercept. They all have the same line of symmetry. And the thing that's changed, it appears, is that the curves are different. And if you watched them in order, well, let me sketch these on my graph paper here. So my y equals x squared, again, 1 squared is 1, 2 squared is 4, 3 squared is 9. So that one's going to look like this. And then there was one that was lower than that. And if you look closely, you should have noticed that that was the y equals 1/2 x squared. And this was y equals x squared. And then there was one that went up steeper than that. And I'm not being too accurate here, but something like that. And that's y equals 2x squared. So again, the things that were the same were the the line of symmetry is the same. It's the equation x equals 0. The vertex of all these is the same, so they all have the same minimum. And the things that are different are the steepness of the lines kind of changed. All right, so you probably noticed that these numbers are changing the curve, the number in front of the x squared. All right, we'll do one more here. Let's go to the next page and do number, actually we're going to do number 4, wherever that one went. All right, so we're skipping here to number 4. It says use what you learned in exercises 1 through 3 to predict what the graph of each will look like. So I'm just going to do, I'm going to pick one that kind of combines a couple things here. Do part B, and you can do the other ones in class. But remember that when we put a number in front of the x squared, that made the curve a lot steeper. And then when we added something on the end, that changed the y-intercept. So y equals x squared is this graph. And what we're going to do is 3x squared. So we know it's going to be steeper than that, so kind of a narrower graph. And we know it's going to be raised up 2 because of that plus 2. So the y-intercept is going to be right there, and then it's going to be really steep. So I'm just guessing, but maybe something like that. So this one's y equals x squared, and this is my guess of what y equals 3x squared plus 2 looks like. And you can check that on your calculator if you want, just to make sure you're doing the right things. All right, let's move on to another problem here, another set of group of equations that we're going to study. We're going to study these, all these equations, x squared plus 2, x squared plus 3x plus 2, and x squared plus 6x plus 2. So basically what we're trying to find out here is what effect does that have on the graph? And one prediction that we can make from the last problems we did is, you notice these all say plus 2 on them. You should realize that that is the y-intercept. So they should all have a y-intercept of 0, 2. And the other prediction we can make is, since all of them are 1x squared, they should all have the same curve, approximately. All right, now we're going to graph that. So I'm going to pause here and get my calculator set up. And I think I'm just going to use a standard. All right, so you can see the equations I put in there. And I'm going to let you watch them as they go so you know which equation is which. But I put them in the same order as they're written in your packet. And I'm going to press zoom standard, and the graphs will appear. There's y equals x squared plus 2, y equals x squared plus 3x plus 2, and y equals x squared plus 6x plus 2. And remember, our prediction said that we were going to have the same y-intercept, and it sure looks like that. There's the y-intercept right there. And we also thought they would have about the same curve. If I were to move this graph down here, it really is the same curve. All right, so I'm going to sketch those. And since I use the standard window, I'll just draw my x and y axis there. All right, so I made my sketch. And what we're going to do now is answer the question B, were our predictions correct? And yeah, we were correct about that. And then we want to just write a sentence or two about how the graphs are similar and how they're different. The similarities are the curve is the same. The y-intercept is the same. And the differences are, you probably noticed that the vertex has changed. So the vertex which also controls the line of symmetry, those are changed. So just kind of predicting here a little bit, what I would guess is that this number there is really affecting where our vertex is and where our line of symmetry is. So we'll probably learn more about that. Let's do one more group of equations. So we're going to skip down here to group 3. Again, we're going to try and predict what's going to be the same about them. And you should remember what this negative does. Remember in that one graph we did in class, that flipped it upside down. So I'm going to predict that the graphs are going to be upside down parabolas. So they're going to have a maximum, parabolas with a maximum. And again, we have the same constant added on to all. So I'm going to predict they all have the same y-intercept. And because of what I saw last, I'm going to just predict that they have different line of symmetries and different vertices. All right, so I'm going to go ahead and graph it and sketch my graph. All right, so I got my sketch here, and I labeled them, and again, you can see that our vertex moved, which is also our line of symmetry, that did move. And you can see that they do all have the same y-intercept, they're all upside down. So it seems like the effect of this -2 was to turn it upside down. You might have also noticed, too, that these graphs are a little narrower than the y = x² graph would be. And the vertices are changed, so I'm kind of thinking that this number in front of the x is controlling where the line of symmetry and the vertex are. All right, that's it. I'm going to do the rest in class with you, and I'll see you tomorrow.